Right. Right. So my second lesson is on numbers. So there are several lessons on this topic. Well, I will cover the following three small topics. One is about divisibility, second about prime numbers and prime factorizations, and the last one will be on how to determine the unit digit of the product of several numbers. Okay. All right, so let's take a look at the following problem. We're trying to show that, here's the proof, yeah, we never do the proof, right? Show that the difference of the two-digit numbers, if we switch the two digits, will be divisible by 9 or divisible by 99, depends on problem. Okay, show that if this two-digit number, if I switch the order, okay, those are two-digit numbers, okay, and if we reverse two digits, this is always divisible by 9, okay, and if we have three digits A, B, C, then if C, B, A, this is going to be divisible by 99, and keep it doing, okay. Now, how do you prove this? Here, A, B are the two-digit numbers, okay? Those are two-digit numbers. But I do not specify two-digit integers numbers yet. I do not specify what the two-digit numbers, but you can check that, right? You know, like 21 minus 12, right? 21 minus 12, that is going to be 9. It's divisible by 9, okay? So no matter what two digits you choose, when you switch two digits, then the difference will be maybe negative, maybe positive, but it's divisible by 9. And you need to prove that, okay? How do you prove that? Because you have to state this general, it's true, right? You have to be true in general. So let's take a look at 21. We are in the base 10 system. Actually 21 is 2 times 10 plus 1, okay? And maybe use this example, you get some ideas. And so 12 is going to be 1 times 10 plus 2, okay? So let's take the difference, right? Do the difference in a different way, okay? That's plus 1, okay, minus 1 times 10 plus 2, okay? So the difference here is a 10, right? And then 1 minus 2 is 1, so that's going to be 9. Now, if I put a general number there, if I put a general number, A minus, right? A minus BA, okay? So if I can express them in this form, like a 2 plus 10 plus 1, then probably can solve the problem. So A, B is two-digit numbers, can be written as A times 10 plus B, right? Minus, and this is B times, 10 times B plus A. Okay, let's remove the parentheses. It's 10A plus B minus 10B minus A, okay? Then we group terms containing A together. So 10A minus 1A is 9A. B minus 10B is negative 9B, okay? So now you will see there's a factor here. And clearly this is always a product of two numbers. But A minus B maybe negative, right? It's possible, but it's still, this is a divisible, is divisible by 9, okay, always. Okay, now this is we do not specify the digits for A and B, then you prove that it's divisible by 9, then this is called the theorem. Okay, in mathematics, this is true in general. Okay, not only true for the specific numbers. And that's so-called a proof, okay? You cannot, you can use the numbers to test it, to check whether this is true. And after you check a couple of times, you cannot jump to the conclusion. You only can make a conjecture in mathematics. Okay, this may be true in general. It's different from doing research in mathematics, different from biology. Biology, when you test it a couple times, different cells, then you immediately jump to the conclusion this may be true. But sometimes they make a, sometimes there's a claim maybe turns out to be wrong because you only based on a few examples, right? So that's why textbooks in biology, always revised. And then you cannot use a textbook in biology 50 years ago to learn biology in college or in high school. You have to use the most recent edition. But you can use a textbook published 50 years ago on calculus or algebra, and you still learn the perfect mathematics. Doesn't matter. Okay. So and sometimes even better, they're written much better. Okay. Okay. So let's look at the digits, the difference of those two numbers. All I have to do is just switch the tens, hundredths digit and the units digit. Okay. I want to show this is divisible by 99. Okay. How can I see that? A, B, C. That's right. This is A times 100 plus B times 10 plus C, right? Right. Then you minus C is 100C, minus 10B. Here plus 10B and plus A. So now you remove the parentheses, okay? 100A, 10B plus C. And then here 100C minus 10B and minus A. And then you find out 10B in the middle is canceled. What is left is 99. 100 minus 1 is 99A. And then C minus 100C is negative 99C. So now you have a common fact, 99. So it's always like that. So this is a divisible by 9. Okay. All right. So sometimes you were wondering why, how can I check whether a number is divisible by 9? If I give it a two-digit number, just one number itself. Here's always, this is the difference of two-digit numbers. Okay, how to check a two-digit number is divisible by 9. Okay, so let's take a look at two-digit number. Okay, how to check a two-digit number divisible by 9. Okay. Well, some of you probably already know that, right? Okay.
To see if that number is divisible by 9.
Okay, can you prove that? You have a super memory. You remember that somebody told you, okay? And so the sum of digits is divisible by 9. Then this two-digit number is divisible by 9. Maybe three-digit number. It's the same. Okay, same statement. All right. So let me show you the proof for two-digit. Okay, this is a two-digit number, right? It's 10A plus B. Okay, but this 10 can be written as 9 plus 1. Okay, then you get 9A plus the sum of those two digits because A plus B. So this is the sum of two digits. This is always divisible by 9. So AB, this is a two-digit number. It's not a product of two numbers, okay? AB is a two-digit number, is divisible by 9 if only if A plus B is divisible by 9, okay? And the 9 is also divisible by 3. So you can have a statement, okay? This in general, this is always true in general, even three-digit number, four-digit number. So we have the following fact, okay? A number, okay, is divisible by 9, or you can also say 3 respectively, right? If and only if the sum of digits, okay, is divisible by 9 or 3. Depends on this is what is the question, right? Divisible by 9 or respectively 3. Okay. So if it changes 9 to 3, then it's the same statement is true. Okay. And believe it or not, let's take a look at three-digit number. Okay. A, B, C. Okay, so 3-digit number is going to be 100A plus 10B plus C. Okay, now I'm going to decompose 100. 100 can be written as 99 plus 1. 10 is going to be 9 plus 1, right? So you multiply this out, then you get a 99A plus A. Then here's 9B plus B, then plus C. Okay, now you combine those two together. Okay, this is always divisible by 9. Okay, and here's the sum of the digits. All right, so a 3-digit number can be written as a multiple of 9 plus the sum of digits. That's why this 3-digit number is divisible by 9 if only if the sum of the digits is divisible by 9. Okay, because this part is always divisible by 9 and 3, of course. Okay, that's the proof. Okay, this is a good problem. And now we are then we're trying to here's a problem. Okay, the product. Okay. The product of 3 consecutive integers must be divisible by 6. How do you see that? Okay, we look at some example. Now, when you see a statement like that, just look at examples first. Okay, right? But that's not proof. This example is the example, right? So, for example, 4, right? 5 and 6. Of course, it's divisible by 6, and 6 is there. Okay, and then 5. No, I'm trying to avoid the 6 because I'm going to begin with 7. Okay, I begin with 7. 7, 8, 9. Why is it divisible by 6? So there's a 3 here in 9, but there's 2 there in 8. It's always divisible by 6. Okay, no matter which 3 consecutive integers you can choose. Now the proof is a little bit difficult. Okay, first all I have to do is just prove that it's divisible by 3. Why? Because the 3 consecutive integers definitely contains 1 even numbers, right? So it's divisible by 2. Then if we can prove that it's divisible by 3, then the product is divisible by 2 and 3. Okay, but why divisible by 3? Because when you write down the natural number, okay, 4, 5, 6, 7, 8. So whenever you choose the 3 consecutive integers, there's always one is a multiple of 3. Okay, it's always, doesn't matter where you choose. And here 3, 4, 5, the 3 is a multiple of 3. 4, 5, 6, 6 is multiple of 3. Okay, and the 5, 6, 7, 6 is multiple of 3. And then you can, so it's from 5, and then from 6 is also, so that's clear. Every 3 consecutive integers, at least one of them is a multiple of 3. If we can prove that, then the conclusion is the product of 3 consecutive integers must be divisible by 6. Okay, because it's even number. This is about okay. Let's talk about the prime numbers, because when we try to express a number as a product of some numbers, and we needed to understand the concept of prime numbers. So prime numbers, okay. Prime numbers are the numbers which can be only divisible by 1 and itself. Okay, so there's a long list of prime numbers, and I hope I hope some of you can memorize those prime numbers, this long list. Okay, some other numbers looks like prime numbers, but they're not actually. Right? And wow, we do have Eric. Eric can write down lots of prime numbers here in the sequence. Okay, 29, next one 31, let's say 37, 41, 43. I hope I never missed any of them. 47, next one is 57, and 53, yeah, 53, 50, all the way to 59, then 61, and 67, 71, 73, 79, 83, 89, 97, and I think one more. Let's stop here. Okay, that's too much. All right. Now those prime numbers. Okay, someone just sitting in front of those prime numbers, trying to see. Okay, can you trying to find some sequence we call the arithmetic sequence of a prime number. Okay. All right, we're trying to find the arithmetic sequence. Okay. Find yeah. Let's try to find an arithmetic sequence of 5 prime numbers. Okay. So let's see if we are able to figure it out. Yeah. All right. For example, if you look at the 3, 5, 7, this is the arithmetic sequence. It increased by 2. Okay, but it's from 7 to 11. No, unfortunately. Okay, unfortunately. Okay. And yeah, because the 9 is not, right? It's not necessary to be consecutive prime numbers. You can jump, okay? So, well, if you focus on those numbers long enough, you will see, okay? You will see, let me write, okay, 5, okay, and 11, jump to that. And from 11 to 17, from 17 to the 23, from 23 to 29. Okay, so this is an arithmetic sequence. It's increased by, always by 6. So that's surprise. Yeah, but 29 plus 6 is not a prime number. 29 plus 6 is 35. 35 is not a prime number. Okay, so those are the, yeah. Yeah, all the prime numbers are other numbers except for 2. Okay, so here's my question. Okay, please do not type to anyone else. Okay, don't post it. I know you know something here. There's no reason to post it here. Okay, if you have answers to my questions, you just post to me directly. Got it? Thank you. Okay. So this is a sequence of a very special one. So you should know that when you ask it to find a arithmetic sequence of 5 prime numbers, then you should come up with this sequence of numbers. Okay. Yeah. So now I'm going to talk about prime factorization, because given a number, you can always try to express as a product of the numbers, okay, prime numbers. And this is a very common question, okay? Factor, for example, yeah. So we did it many times, fact the following numbers 4, 2, 4, 2, okay? Let's try it. Yeah, factor 4, 2, 4, 2. So of course, this contains factor of 2 because divisible by, it's an even number, right? It's an even number. let's see. So 4, 4, 2, and 4, 2. Now, what is the best way to do? Because you see that those two numbers are repeated. So it's 4, 2, right? And 4,200 plus 42. Okay. Then you can take a 42 out. Okay. You can take a 42 out because 42 times 100 plus 42 times 1. So you get 42 times 101. Okay. Now, only dimension that 101 is a prime number. So this is the rest part is just trying to factor 42. Okay. 3 times, right? 2 times 3 times 7. And then times 102. 101. 101 is a larger number. Okay. Okay. Our next problem. Okay. We know that the product of 3 consecutive numbers is going consecutive other number is going to be 315. Can you find those numbers? Consecutive odd numbers, okay, odd integers is 315. Okay. What are the numbers? You can assume that, yeah. What are these numbers? What is the best way to solve this problem? You know 3 consecutive other numbers multiplied together is going to be 315. Right? So Eric, do not post your comments public. All right. So my suggestion is this is a product going to be 3 numbers, right? So maybe in that form, because those other numbers, difference between 2 numbers is going to be 2. If you write the 1 in the middle, then the other 2 will be plus minus 2. Increase by 2, decrease by 2, right? Because those are other numbers. So this will be the odd, okay? And of course, odd number plus 2 is still an odd number. So this is the curve, right? So this is supposed to be 350, but if you try to solve this equation, it's difficult. So you have to do the opposite way. You see the result, 315. So you divide the 315, you see that this is going to be divisible by 9. It is divisible by 9, okay? And because of digits, we already mentioned that the sum of digits is going to be 9, divisible by 9. So sum of digits is 9, so it's divisible by 9. Divisible by 9, okay, since 3 plus 1 plus 5 equals 9. Okay, the sum of digits. So now you can just divide by 9, okay? And that is going to be, I think after you divide by 9, it's going to be 35. Okay? Then 35 is 5 times 7, and then you get almost a proper factorization. You don't need to factor 9, but you see that this is a 3 consecutive odd numbers. So you solve the problem. Okay. Okay. Now, there's an interesting notation. It's called nfactorial. Nfactorial is going to be 1 times 2 times 3 times 4. Okay. Times 4 times 5 all the way to n. That's so-called n factorial. And so this number increases very fast. Okay, it is faster than any exponential stuff. You can check that. Okay, for example, 100 factorial. This will be a huge number. Okay, even you cannot write down a piece of paper. But at the same time, you notice there's a lot of zeros at the end. For example, n factorial, right? Let's say begin with the 5 factorial. 1, 2, 3, 4, and 5, right? Right? So that is going to be 120. So you get 0 here, right? Then you get 10 factorial, then you get another 0. So you're trying to figure out how many zeros you can get at the end. Okay, so so here's the point. In order to make 0, you have to have 2 times 5. That's going to be 10. Right? This is a key point, key identity. So only when 10 meets 5, then you get 0, get to 10. So you produce a 0 at the end of the plot, at the end of the number. Okay. All right. So now, right. So now, so let's take a look at 10 factorial. 10 factorial is 1 times 2 times 3 times 4, 5, 6, 7, 8, 9, 10. So I want to know how many zeros if you multiply them out at the end of the number. But even you don't get a specific value of the product, okay? Can we figure out how many zeros? So I want to see something here, 0, 0, 0. You know, how many zeros there, right? How many zeros here? Yeah, it depends on, you know, how many 2s, how many 5s there, right? So in order to get 0, you have to have a 2, you have to have 5. But the product of those numbers, okay, how many 5 there? Because 10 is going to be 2 times 5. So you have 5 here, you have 5 here. So there's 2 5. But there will be more than 2 2s there, okay? So there are too many 2s there. So that's why you can, 5 meets 2, you get 10, okay? That's 2 5s, you get 2 10s, right? You can always get 2 10s because you you get enough. Yeah, there's enough 2 there. So the 2 times 5. Yeah. So in general, if we can figure out 2 to a certain power, 5 to certain power, and then all the other factors which does not contain 2 or 5, then in general P is always greater than Q. So then if we expand it, if we can figure out how many factors 5, then you can always, okay, so the number of the zeros at the end corresponds to the power of a 5, right? So if you look at the 10 factorial, okay, 10 factorial, let's see, let's try to find out 2 to certain power, right? 5 to certain power, and then some other factors. So my question is, what is 2, what is Q? Okay. What is 2 and what? I think it's easy to see Q must be 2. Okay, Q is a 2, clear. Q is a 2 is clear. But how many factors of 2 there? Right. Well, you can count. Let's go back to here. Okay. You can count. So there's 1 2 there, it's 2 2 there, and 1 2 there, and 3 2 there, and there's 1 2 in the 10. So I have a 1 plus 2 plus 1, 4, 4 plus 3, 7, 7 plus 8. Okay, so it's going to be 8. Okay. So that'll be more enough 2 there. So 2 times 5 is going to be 10. Okay, So that's why it's 2. I just need the 2 twos there. Okay, then I have this, and I get 2 zeros. Okay, that's 2 zeros. Okay, the factor of 2 to power 6 still there. I only use 2 factors to produce 0 when multiplied 5. Okay, so here's my question. Okay, how many zeros are at the end of this integer 20 factorial over 7 factorial and 13 factorial? So hey, Erica, what's the answer? Okay, don't type any nonsense here. Okay, I give you several warnings already. Okay, just give me an answer privately. Give me the answer. That's all I need. Okay, don't show to everybody. Clear? Okay, so what's the answer? How many zeros there? Okay, thank you. All right, first of all, let's understand the factorial. Okay, 20 factorial can be written as 13 factorial, and then 14, 15, 16, 17, 18, 19, 20, and here divided by 7 factorial, 13 factorial. So 13 factorial is gone, okay? And the 7 factorial, I really care about 7 factorial is 1 times 2 times 3 times 4, 5, 6, and 7, okay? Now, first of all, let's see how many 2's you're going to get. On the top, let's collect the factor of 2. I have a 1, 2. I have a 4 2's here because 2, right? So I have a 2. I have a 1, 2 here. Then this is a 4 times 5. So I get 2 2's here. Okay. In the denominator, I have 1, 2, have a 2, 2, has a, and a 1, 2. So, the power of 2 is going to be 1 plus 4 plus 1 plus 2, which is going to be 8. 8 minus 4, its power is 4. Okay. Then the question is how many factor 5 there? Okay. I have a 1 here, right? Another one from here. But I also have to delete a 1, right, in the denominator. So it's a 1. Then you multiply by other numbers. Okay. So 1, 0 at the end. That's true. Okay. You see, it's not. It's simple, but you have to be careful. Okay. You have to be careful to answer the questions. Okay. You have to be careful with the questions. So the answer here would be something, 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 and I get 0 because 2 times 5, 0. I really don't care about this part. Okay. Yeah, I think the answer is 1. Okay, that's only 1 0 there. All right. All right, our next problem is about figured out the units digit. Okay, how to find the units digit. So let's do the first problem. Okay, so units digit. What is the units digit of 12 to the 2021? This year 2021. When you grow up, in a couple years later, 2023 or 2024, when you take the contest. Okay, but you know how to solve the problem, then you can figure it out. Right? Okay. So any ideas, any tricks? Eric, I'll give you many warnings already. I ask you stop typing anything else, okay? I just give me the answer if you have answers. You're too active. All right, so what is the units digit of 12 to the power 2021? Now, of course, this power is so large, but we're trying to figure out a pattern. And maybe there's a short way to solve the problem, quick way. Okay, find the pattern, yes. Okay. So usually the last digit of the number determines the last digit, okay? So you don't need to know the other digits, okay? So if you have a number, okay, like some number a to the power k, okay, the units digit actually is determined by the units digit of a and the power k, okay? So so let's take a look at it. 12 to the 1, and then the last digit is going to be 2, right? I'm going to just write 2 here, okay? And then 12 squared, and the 2 times 2 is 4, so the last digit, the units digit is going to be 4. Okay, so this side is the units digit, okay? I won't really call the units digit. Okay, and the 12 cubed, and the 2 times 4 is going to be 8. Okay, yeah, 12 to the 4th power, and 8 times 2 is going to be 6. Okay, so those are the units digits changing. However, 12 to the 5th, and then this will be, this will be 12 to the 4th times, right? 12 to the 4th times 12. So 12 to the 4th is the units digit is 6. And 6 times the unit digits of 12. Okay, the 6 times 2. Okay, so it's the last the digits, it's going to be 2. Okay, it's going to be 2. Okay. So you get a periodical function. You get a periodic function. Okay, to the 6 is going to be 4, 2 to the 7th, and 2 times 4 is 8. Okay, and the 2 to the 8th, and then 2 times 8 is 60. So it's always, 2, 4, 6, 8, 6, 2, 4, 8, 6. It's repeating. Okay, it's repeating. Now, (2021), okay, if you want to divide by 4, I just want to know how many blocks of 4 digits, 4 integers here, okay, from 1 to 2021. Okay, so this is this is and actually you can divide by 4, 505 times 4, but then there's an extra one here, 1. Okay, so if you divide by 4, the remainder is 1. The quotient is 505. Okay.
So is it 4 as a units digit?
Okay, 200. So what is the units digit of and the 12 to the 2021, right? Now, okay, you have a 505. blocks of 4 and plus 1. So all I have to do is just look at, this is the last one is here's a 6, okay? And throughout 2021, you repeat it, okay? And that's it, it's just repeating. And it's 4, so this should be the answer, right? Yeah, that's the top one. Okay. But that is the answer. So 2486, 2486, 2486, it's repeating. Okay. So the answer is 2. The answer is 2. Now, the same idea, we can apply, how do we figure it out the remainder when you divide some number, okay? This is, well, we have, let's see, let me talk about the general theory, okay? We try to divide n, divide by p, right? A number divided by p. And then you get a remainder, okay? Remainder is r, so n equals p times quotient q and r. So this is a remainder. Okay. Now in mathematics, okay, if you take a look at the power, and you find out if you multiply this out, you will find out that you have lots of stuff here times p, n plus r to the k's power. Okay, so that's why it's a divisibility as a remainder of n to the k's power. Okay, is completely determined by the last one, r to the k's power. Okay. And there's a general formula in mathematics like x plus y squared is x squared plus 2xy and plus y squared, right? This is y squared here. And this part is divisible by, contains x, okay? Then x plus y cubed is x cubed plus 3x squared y plus 3xy squared plus 3y plus y cubed. So you see this is y cubed, and this part contains x. All the terms contain x. Okay, contains x. Okay, so get the idea, get a pretty good idea. So nk equals pq plus r to the k. And then when you multiply this out, you will get something pq plus r to the power k. And this part is divisible by p. So when you divide n to the power k, this is the remainder is completely determined by the last one. Okay. Okay. So the remainder is determined by the last one. All right. So now I'm going to take a look. Yeah, in this case, we will say they have the same remainder. So nk and r to the power k have the same remainder when divided by p. Okay. All right, so take a look at the following problem. 11 to the 2020 is divided by 2. What is the remainder? Now, the remainder when divided by 2 is either 0 or 1, okay? So either 0 or 1. Can we quickly figure it out, right? Either 0 or 1, right? What you can do is, okay, what I can do is 11 2021 and 2020 is going to be 11 squared times, okay, times 101. Okay. But 11 squared can be written in the form 121. Right? But 121 is going to be 12. It's divided by, if it's divided by, yeah, I should say it's 2 times 60, right? And plus 1. Okay, so all of these terms, okay, this will completely determined by something. You can take this out and plus 1 to the 101. So this is always divisible by 2. So what they get is that the remainder is determined by the last term. It's 101. Okay, so we call it trim. Yeah, this we will learn a little bit more about this when it's in the advanced math class. Okay, this is called the trimming method because the number is too huge, too large. So what they do is just replace 11 by its remainder. Okay, then you can simplify it. This just equal to the last digit. Okay, because it's divisible by 11. Okay, so you only determine by the first one. This is the last one. This is the 1. So the remainder should be 1, not 0. Okay, if it's divided by 2. If it's divided by 2. Okay. Well, okay, actually we're going to spend more time in the advanced class for this type of problems. Okay, and yeah. So our next topic I was trying to look at is how many numbers we can get. Okay, so we consider 3 and 4. Okay, we consider 3 and 4. Okay, consider 3 and 4, those two numbers. Then 3n plus 4m. Here n, m are positive and non-negative integers. Okay, can we express all the integers using this form? That's a research problem, right? Can we express let's try 5. I cannot, right? So 3 plus 4, 3 something plus 4 something, I cannot make it a 5. I cannot make it a 5. Okay, so where's the number? Oops, my 5 is gone. Just a second. Okay. Okay, we try to express it. What kind of numbers you're going to express? Okay, so we will see that I begin with a 5. I cannot 5. 5. I cannot make it. I cannot express in this form any of my integers. Okay, but 6 I can. 6, 3 times 2, 4. 4 times 0. Okay, 7. All the integers after 6, it's surprise, can be expressed. 7 is 3 times 1, 4 times 1, right? Yeah. And 8, let's see. 8 is 3 times 0 and 4 times 2. Right? Yeah. 9 is going to be 3 times 0 and 4 times 0. And then we always use the 4 and the 3 and the 4. And the 10. Okay. 10, can we do the 10? Yeah. 10, I think 3 times 2 and 4 times 1. Okay. Yeah. So you will see that any integer, it's hard to prove, okay? Any integer greater than, here's my conclusion, okay? Any integer, okay, greater than equals 6 can be expressed as 3n plus 4n, okay, for some non-negative integers. But it's not easy to prove, but this is based on what we say. We are sometimes, we just want to know, yeah, this may be, if before you prove it, you can only call it a conjecture, okay? And you cannot call it a theorem or fact. But if you are the biologist, after you did all this, make all those observations, you write a paper, you claim that, okay, any integer greater than or equal 6 it can be expressed in this form. But then, 10 years later, then you have much better equipment, you make observe more, then you find, oops, that's wrong. Okay, there's some hidden, there's some example, common example. So that's why you have to revise the textbook. Okay, I gives you warning. Science is not 100% always correct. Okay, that's called science. Okay, science is that. So this is a kind of process. It gradually completed. Okay, it takes a while, and we can only say that based on our observation, we conclude that, or we guess, and then that's called science. Okay, science is not always 100% correct. Right. So there's a concept, okay, notation in mathematics, okay, for two numbers. When we say this notation means P and Q do not have a common fact, okay? So for example, 3 and 4, it's going to be one. We call it relative prime in some books, okay? And then 4 and 5, that's going to be 1, okay? So now let me state this is a very important theorem in mathematics, okay? So that is a theorem, it's proved, okay? If P and Q is 1, okay, that means they do not have a common fact, okay? Then the greatest integer which cannot be expressed as Pn plus Qn for some non-negative integer is, we find out, Pq minus P minus Q, okay? So that is a fact. So let's see, let's look at our example. 3 and 4, right, do not have a common fact. So 3 times 4 minus 3 minus 4 is going to be what? Right? So that is a number 12 minus 7. Okay, that's going to be 5. Right? So 5 is the greatest integer which cannot be expressed in that form. So any number greater than 5 can be expressed in that, but that's not easy to prove. That is proved by mathematicians. Okay, so let's take a look at example. 6 and 7 equals 1, right? So that do not have a common fact. Let's calculate 6 times 7 minus 6 minus 7. Okay, what is that number? Okay, that number is going to be 42 minus 13. That's going to be 29. Okay, So 29 cannot be expressed in this form, but any number above 29 can be expressed in this form. That's weird, right? So 29 cannot be expressed in the form like that here, nm, a positive, non-negative integer, right? But 30, yes, okay? And the 30 is going to be 6 times 5 and plus 7 times 0. But 29 you cannot. So that is an interesting problem. So if you know this fact, you can solve the problem quickly. Okay. At the end, yeah, let's look at the last problem. So what is the unit digit of 1, 2, 3, 4, 5, 6, 7 times 4, 6, 6, 7, 2, 4 plus 2029? Okay, I hope you guys can figure it out. I'll give you 1 minute to think about it. Don't try to use a calculator to prove. Right. Rebecca, do you have answers? You should have answers, right? Yeah, you have it. I think. Okay. All right. I told you the unit digit of a product of two numbers is completely determined by the unit digit of each number. Okay. And we only need to record the last digit here. Okay, that's it. So 28 plus 9. Okay, 28 plus 9 is going to be 37, so the unit digit is 7. Okay. So not 37, we're talking about the unit digit. Now, why is this product, the unit digit only determined by the unit digit of each number? That is the reason is 10a plus, let's say 10a plus b, right? 10c plus d, right? When you multiply this out, let's see. When you multiply this out, you try to determine the unit digits, right? So that's 2-digit number, 2-digit number. So 10 times 10 is 100 AC, then 10 BC, then 10 AD, then B and D. And clearly this part is divisible by 10. So 10 something, right? And the B times D. So this is a product, the product of the unit digit of each number. So clearly, you just need to consider the unit digit. Okay, then because the unit digit of the product is completely determined by the product of the unit digit. The unit digit of the product of two numbers is going to be determined by the product of the unit digit. So that's why you only need to consider, this is theory, you only need to consider B and D when you try to determine the last digit, because this, as you can see that, okay, if you multiply them out, and here is always divided by 10, and B times D shows up there at the end, so you can determine by the unit digit is completely determined by B times D. All right, so that's for today's class. Now remember,